Hey, good afternoon, Giuliano D'Auria from SELEX. So I will be giving you a flavor of innovation in airport systems, new systems being developed, coming onto the to the market. And of course, what I'll be saying will map onto what is being done in CESAR, which is not surprising because CESAR is determining what the future of the ATM world will be, and we have to follow this trend. So I come from the ground industry, so you may be asking, what has the ground industry got to say about legal liability and all these aspects? Well, certainly we are interested in developing fancy tools, fancy developments which can go into the market. That's our prime interest, our prime concern. But it doesn't end there. Clearly, we have to look downstream, what comes after the actual development. And we have to consider, it is in our interest to consider the implications this has. And of course, implications mean the operational implications, how the controllers are going to use our systems, and but a range of implications, including the legal aspects, liabilities, etc. So it is in our interest to open up a market, not surprisingly, and we want to make sure that we have no showstoppers, and which is why our interests go beyond the just pure development of fancy new tools and systems. So it is all very relevant also for the ground industry. Okay, this is a moment we check, and okay, let's, okay. So this is just a view of the ATM world. We have all the actors there, the control tower, the ATC, the ACC centers, the airport, the airlines, the satellite systems, the radars. It's a complex world. It's a complex world. What I will do now is to go through some of the innovative systems which are being developed in various stages of maturity. And okay, we go ahead. These are the systems I will be going through, so, or the functionalities, let's put it this way, surveillance, SCA, ground management, etc. We'll go through these. And as far as I will occasionally highlight some implications in terms of legal aspects, liability aspects, which are of interest to this audience. So let's start from surveillance. Surveillance is a starting point for the whole chain. We need surveillance in order to build our automated systems. It's a starting point. And of course, if we don't get the surveillance right, as a chain reaction, the rest of the automated systems will have some problems. So it's a starting point. We have traditional sensors, which have been around for many years, the radars, but we also have more advanced systems which are coming on right now. I just highlight the ADS-B and multilateration, and which are especially important also in an airport environment where in the terminal area there's so much clutter that traditional radars would not really be able to be of much help around the terminal area. Just a few more, some words on next slide. ADS-B, okay. ADS-B is, it relies on the fact that the position of the aircraft is determined, is provided by the aircraft, broadcasting its position, which it may take from GPS or its own inertial systems or whatever. And this is displayed to the controller. So if you click, let's just check. No, I think you have to, okay. And that's, I here highlight a first point. So the position of the aircraft is coming from the aircraft. What happens if this position is not accurate? Question mark. So this is the ground system is receiving the position from the aircraft. So we're relying on the fact that that this is a reliable position. but okay, it comes from another actor. Let's move ahead. This is just a slide on TISB. This is not specially, it's just the TISB is the opposite of ADSB in a way. It's the ground system providing a situational awareness on board the aircraft on the basis of all the surveillance data available to the ground controller. We upload this, and you can click again, and provide this picture to the aircraft on board. And again, this is aiming at providing a situational awareness and so that the pilot is aware of the surrounding traffic. Let's move ahead and to the next point, surface conflict alert. And here we're coming to the really, so surveillance is a starting point. Of course, we have to have that. And on this basis, we can start developing interesting tools, automated tools, aiding the controller. Surface conflict alert, what does that do? What do we do with that? The surface receives surveillance information and airport environment data updates. And on this basis, through sophisticated algorithms, we identify potentially dangerous situations and highlighting this to the controller by warning and alerting messages. So this is an important tool. The algorithms may be very sophisticated, but the point I wish to highlight here is that it doesn't stop here. It's not enough having sophisticated algorithms. What we need is for the controller to buy into it and the acceptability on the part of the controller. This is crucial. The controller will then be responsible for its use and adoption. And this is where the relationship with a human in the loop is essential. And this is why it's not enough just to develop the system. We have to test it in complex simulation environments, real-time simulations, to collect the controller feedback and to assess his acceptability for who's actually going to be operating this. And this has been done in past projects, EMMA as an example, but of course now in César. It's validating that these ideas, these tools, however sophisticated, can actually be used by who will be responsible for their use. Another area, let's move ahead, of automation is maybe inappropriately defined here as ground route management, but I'm collecting here tools such as the departure manager or runway manager, which is aiding the controller providing optimized use of the runway, which is a limited resource, of course, considering all the constraints which there may be. Time constraints and procedures may change because of the meteo conditions. So this is one set of functionality. Then we have the route planner. The route planner provides a controller with the best taxi route to the runway. Now, how you define best? Okay, this is an interesting point, but clearly, it has to take into account time constraints, maybe minimum distance or minimum time to get to the runway. There's a whole range of parameters which have to be built into complex algorithms, and the result is a suggested route for the aircraft from the stand to the runway. Once we have this, of course, the divergency check is a natural next step through which we are able to advise the controller if the aircraft is actually following the designed route. The next slide just goes into a little bit more detail, but it's the same principle. I mean, the determination for each departing aircraft of the best and conflict-free routes from the gate to the runway And again, but this functionality has to then be accepted by the controller, and which is why the principle has to be validated in simulations and real-time simulations environments. The next slide is just a screenshot of an example of how maybe the route to the runway can be highlighted in green and maybe also displayed on the flight strip. Let's move on to the next point. So ideally, once we, with a route planner, we identify the optimal route, taxi route, and this is then transmitted to the aircraft on board, maybe by means of CPDLC, which is another important functionality, controller-pilot data link connection. And the idea here is to use data link rather than voice. Earlier today we were talking about, maybe in the case of the Linate incident, the confusion which voice may give rise to, I mean misunderstandings. So the idea here is to avoid all this by using data link, and an example is just displayed here. We have the controller maybe giving a clearance, if you click again, which is sent up to the aircraft again, displayed onto the screen on board the aircraft, clicking again. The pilot acknowledges this and sends back a message. Again, the idea being to avoid misunderstandings which may arise from voice communications. Okay, again. Okay, now we enter, I'm introducing another aspect which is really an example of where automation really can be useful in the tower environment. What's displayed here is the simple layout of an airport. Can I just see if I use this, does this work? Sorry, it goes backwards. I know. So. Okay. Okay, so I'm in control now. So I have responsibility as the. So this is a simple airport layout. One runway, parking bays, taxiways, and obviously, depending, every airport has its own operational environment, but in this simple layout, we would have maybe an apron controller responsible for the aircraft at the parking bays, and then the ground controller responsible for the taxiways, and then we have the tower controller for the runways. This is a simple case. A more complex case is displayed here. Maybe two runways. Maybe we have situations in which the aircraft, as it passes, going towards runway 2, it will need to change responsibility. The controller responsible for the pilot will be maybe ground controller number 1, ground controller 1, and will then be passed over to ground controller 2, and then to the tower for the runway 2. There's a range of options which may be taken depending on where the aircraft is going in this more complex layout. Clearly, what could be of assistance here is that the system behind this is able to follow this workflow. And this is what is displayed here. So what, and maybe actually follow this workflow, providing automation, helping the controller, supporting the controller in this flow. And so the transfers on control from the various controller positions, which reflect the operational layout. And again, what would be an advantage is to have the controls which are enabled for each controller depending on the status of the aircraft, so that it is only possible for controller 1 to send the aircraft to transfer the control to the correct controller at the downstream the workflow. And this is where, in this automation, this is a clear example where automation can be of assistance. But, so what is the message here? The message is that as industry, we can develop systems, complex systems, however complex you like, we can do it. But the story does not end here. However automated the system may be, there will come a point at which the system needs to interface with the human in the loop, and the human must be able to connect, somehow connect with the system, automated system. There must be an interface, a human-machine interface, if you like, capable of ensuring that a human is able to operate the system. And this is, in a way, the bottleneck. The system may be automated and advanced as you like, but the bottleneck is the interface with the human. And this is where we have to work on. And this is why it is required to take a human-centric approach and perform these validation of the systems to see how they actually operate in an operational environment, because this will ensure the buy-in and of the system. What is displayed here is just a few screenshots of innovative interfaces. This is a touch screen, okay, very, very modern, but is it acceptable for who's actually going to be using the system? This is a key point. Another, so electronic flight strips, this is the trend. This is where we're going towards. This goes back to the previous slide of the electronic flight strips being able to follow the workflow, the workflow of the aircraft as it goes through the various stages and the various commands which are possible from the orders coming out from the electronic flight strips being dependent on the status of the aircraft, so that it is a real assistance to the controller. All this, of course, is very nice, but has to be validated. Okay. Other examples of flight strips and the departure clearances being sent out directly from the flight strips. So now this leads on to the last main feature I wanted to highlight in this presentation. It's the system interoperability. Interoperability is a buzzword. It's quite fashionable to talk about interoperability. Interoperability indeed is the basis through which it's possible to achieve sharing of information among the various stakeholders. And why do we need sharing of information? Well, just to put it very simply, if we share information, a common set of information, we are probably able to provide or to optimize the decisions, and the optimized decisions are a basis to face a lot of the challenges of capacity and safety, etc. So interoperability and sharing of information. In a way, we move on to this slide. When I talked about the system being able to follow the workflow of an aircraft from the apron controller to the ground controller to the tower controller, this in itself is an example of interoperability, although it's a very simple example because we're remaining within a tower environment. The idea here is to go beyond the tower environment and provide interoperability sharing of information beyond that. And the first level for this is a sharing of information between tower and approach or ACC environment. This is a first level of extending the interoperability beyond the tower. if we go beyond that, even more ambitious, is the idea of sharing information beyond the ANSP towards other stakeholders. And what comes to mind here is the airport operator or the airlines or various airlines. And this is an important extension. So this is basically what I have in mind here when I talk about interoperability. So at a first level, the objective is to ensure that ATC systems geographically located at different control centers covering completely different phases of flight are seen as a single ATC system, ensuring reliable integration between area approach and aerodrome control centers. This is a first level within the ANSP, if you like. And then beyond that, the objective is to allow information sharing between air traffic service provider, airport operator, and airline. And this opens a way for collaborative decision-making processes and the optimization of processes through this broad sharing of information. These principles are just elaborated a little bit further here. So again, the sharing of flight data between an ACC and its tower. This is the first level. And beyond that, the sharing of information between the air traffic service provider and the stakeholders, airport operator and aircraft operator. Again, when we talk about sharing information, this opens up the question of what if this information that is being shared is corrupted. And of course, this is opens up. It was actually briefly mentioned this morning. It opens up interesting questions over liability. Who is responsible for this corrupt data, and which is then being pooled together? And just to highlight a point, we've been talking about catastrophic events resulting from errors. This was the spirit of most presentations, but let us not forget that we're not only talking about catastrophic events. We may have not catastrophic events, but nonetheless important events. I'm thinking of commercial confidentiality. There are maybe issues which airlines do not want to share with the other airlines, and if this is if something goes wrong in the sharing of this information, okay, this is just may lead to some problems, not in terms of life safety, but in terms of the commercial implications this may have. So this basically ends the main part of my presentation. What is my main message? My main message is that as ground industry, we like developing fancy tools, functionalities, but we are also interested, believe it or not, in ensuring that there is a market for these tools and functionalities. And that means that we're interested in implications these have on the whatever. So operational implications or maybe legal implications. Which is why this is all very relevant for us. It is in our interest to make sure that these aspects are covered and taken into account. When it comes to the operational implications, this is why we have projects, research projects, including CESAR activity, which takes the validation of the tools very, very seriously. And these last slides are very rapidly go through them. It's what our involvement in CESAR and the validation activity, how we are positioned in this. We collaborate. We're working with ENAV on their industrial base platform, and for the airport side, that means Malpensa. Everything is swim-based, and again, the key point is that in all these, we have various exercises which we are performing in 2012, for instance, and the functionalities there are, not surprisingly, most of the functionalities I've been mentioning today. So the HMI, the conflict, SCA, route planner, guidance, all these functionalities which I've been mentioning. And again, there's more to come in the next years. Supervision, runway management tools, integration between A-man, S-man, and D-man, remotely operated towers, which we mentioned before, a range of prototypes. But the key message is it is not enough to develop these prototypes. We have to work with the controllers, and this is the great opportunity which is given to us by CESAR. Thank you.